Hello and welcome to the second part of our tutorial series on creating breathtaking skies using volumetric clouds in Unity. And again, we are very happy to tell you that this video is sponsored by Unity. In this tutorial you will learn advanced customization of Unity's volumetric clouds using both the advanced and manual customization options. You will learn the pros and cons of each option and when best to use them. You will learn how to create and author texture assets required for each option. And by the end of this tutorial, you will have mastery over Unity's volumetric clouds and the knowledge to create endless cloud variations for your projects. Please be aware that this guide builds on foundational concepts discussed in part 1 of the Volumetric Clouds Mastery series, such as terminology, project setup and scene setup, which we highly recommend you check out first. The first of the two advanced customization options we will look at is advanced customization. The main advantage of advanced customization over simple custom customization discussed in part 1 of this tutorial series is that we have control over cloud coverage. So unlike with simple custom customization, where cloud coverage is consistent, we can use texture maps to specify where we want clouds to appear in the sky and how dense they appear. We also have independent control over multiple cloud layers, or in other words, cloud types within the cloud volume. This, for example, enables us to create areas of the sky with thin light clouds and other areas with thick fluffy clouds. Finally, we have control of what is known as a Rainmap. The Rainmap lets us control the density of clouds at specific locations, enabling us to create skies with a combination of both thick, dense rain clouds and light clouds. Now that we have a high-level understanding of Unity's volumetric clouds advanced customization, let's look at how to get everything set up. For this tutorial, let's create a new scene. Create a basic outdoors HDRP scene. Give it a name of your choice. I'll call mine Volumetric Clouds Advanced. When done, click Save. In the new scene, check that the scene view camera far clipping plane is set to around 100,000, so that we can see the clouds rendered to the horizon when using local clouds, and that the scene effects are set to always refresh. Next, head over to the Sky and Fog volume in the hierarchy, and with the Sky and Fog volume selected, check that the Volumetric Clouds override is visible and active within the volume component in the inspector. If not visible, click Add Override and navigate to Sky, Volumetric Clouds. In the Volumetric Clouds override, set Cloud Control to Advanced. You will now see the advanced customization settings. Before we begin customizing our clouds, scroll down to Quality. For this tutorial, we want our clouds to be rendered in high quality. So we are going to turn up the temporal accumulation factor to 1 and set num primary steps to around 256. Head back to the Cloud Control Advanced settings and set the cloud map resolution to Ultra 256 by 256 and set the shape factor to 0. This will enable us to better see how texture maps affect the shape and coverage of the clouds. Then, in the Visual Environment override, under the wind, set global speed to 0 so that the clouds don't move. Now let's take a look at the advanced settings. The way Unity's advanced properties work is by providing us with texture inputs to control cloud coverage of different cloud types. Each cloud type, Cumulus, Alto, Stratos and Cumulonimbus, form in the real world at different levels and ranges of altitude. The first texture input, Cumulus map, represents low-lying clouds known as cumulus clouds. Cumulus clouds form at an altitude range of 200 to 2000 meters. In Unity, these clouds render in the lower third of the cloud volume. The Alto Stratus map represents mid-level clouds known as Alto Stratus or Alto Cumulus, which form at an altitude of 2000 to 7000 meters, depending on the region of the world. In Unity, these clouds render in the center of the volume. The third cloud texture input, Cumulonimbus map, represents Cumulonimbus clouds. Cumulonimbus clouds form in an altitude range of 500 to 16,000 meters depending on the region, and reach up to the tropopause, the atmospheric boundary, giving them their signature flat top. In Unity, these clouds render throughout the entire volume and override the Cumulus and Alto Stratos maps. The final texture input that advanced customization provides is the Rainmap. Rather than just giving us control over the global density, the Rainmap lets us specify where we want more or less cloud density, enabling us to simulate clouds with varying amounts of water and ice. Let's look at how texture maps affect the rendering of clouds. We will go through how to author textures for advanced customization shortly, but I have created some texture maps for this part of the tutorial for each cloud type. You can access the Unity package via the link below. For the Cumulus map, you will see that the texture map contains a black background and a white circle. For the Alto Stratos map, you will see that the texture map contains a black background with a white triangle. And for the Cumulonimbus map, you will see that the texture map contains a black background with a white square. Let's position our scene view camera above the clouds to see how these textures affect the rendering of the volumetric clouds. Let's create 3 game objects to quickly jump between the ground, the clouds and a view of the clouds from above. Create one game object called Ground View, a second called Above Cloud View, and the third called Cloud View. We set the transforms and set the Above Cloud View game object's position in the y-axis to 20,000. The Ground View game object position in the y-axis to around 10, and the Cloud View position in the y-axis to 3,500. Now select the Above Cloud View game object and with the mouse cursor in the scene view, press F to move to it. Now select the sky and fog volume in the hierarchy and activate the Cumulus map in the inspector. Drag the Cumulus map texture into the texture slot. You will see that a circular shaped cloud appears in the scene. If your clouds are too far away, you can adjust the cloud map offset to position them closer to the scene camera. Activate the Alto Stratos map and drag the Alto Stratos map texture into the texture slot. This time you will see a triangular shaped cloud appear. Finally, let's do the same for the Cumulonimbus map. You can now see a large square cloud appear. What you will also notice is that the textures were created to make the clouds overlap and intersect with each other. This should give you a better idea of how each texture slot can be used to render various cloud layers and types, as well as how they affect and override each other. To see this clearly, select the Cloud View game object and with the mouse cursor in the scene view, press the F key to move the scene camera between the clouds. You can see that the Cumulus texture renders clouds in the lower section of the volume. The Alto Stratos texture renders clouds in the middle of the volume. And the Cumulonimbus map renders a large cloud through the entire volume, overriding both the Cumulus and Alto Stratos cloud layers. You can now see how input texture maps are used by Unity's advanced customization settings to specify where clouds are rendered in the sky and their location within the volume. Next, we will look at how we can use the texture maps to control the cloud density of the Cumulus and Alto Stratos layer, the vertical coverage of the Cumulonimbus clouds, as well as the amount of rain in the clouds. In the downloadable Unity package, we have included 3 textures for each advanced cloud type with 25% gray. When we drag the Cumulus map with 25% gray into the texture slot, you can clearly see that we get a significantly less dense cloud. We get the same effect when we do the same with the Alto Stratos map, a cloud with less density. When using gradient values in your texture maps, there is one minor technical limitation to be aware of when working with the density of your cloud layers. If your Cumulus and Alto Stratos clouds overlap, the highest density value will be used throughout the vertical axis of the cloud volume. In other words, you cannot create light, thin clouds directly above or beneath thick rain clouds. The Cumulonimbus map works a little differently. For the Cumulonimbus map, we have also provided 3 more grayscale textures: 50% gray, 75% gray, and a radial gradient, to make it clearer how grayscale values affect the Cumulonimbus clouds. Let's start by dragging in the Cumulonimbus texture with 25% gray. You will notice that the density in the top and bottom layers stay the same, but we have a gap in the center. As we increase the grayscale values in the texture, the gap begins to close. So with the Cumulonimbus map, we don't use grayscale values to control the density of the cloud. Instead, the grayscale values controls the shape of the clouds in the vertical axis of the volume. To show you what's actually going on here, let's drag in the final texture, the Cumulonimbus gradient. By using gradients and textures for the Cumulonimbus clouds, you can see that we can simulate the signature shape that Cumulonimbus clouds have in the real world. The final texture slots to consider is the Rainmap. This texture enables us to specify where we want more or less rain in the clouds. To see how this works, drag the provided Rainmap texture into the Rainmap slot. You will now see darkening over 1/2 of the spherical cumulus cloud. To see this more clearly, reduce the density multiplier to around 0.1. Lower grayscale values equal more rain, resulting in darker clouds, and higher grayscale values result in less rain, resulting in lighter clouds. Now that we know how texture maps are used to render the volumetric clouds, let's look at how to author texture maps for the advanced settings as well as the import settings to consider. Authoring texture maps for Unity's advanced volumetric cloud settings is relatively straightforward. In the volumetric cloud shape settings, we can specify the cloud map resolution starting from 32 by 32 pixels up to 256 by 256 pixels, depending on the level of detail we require. The textures themselves are simple black and white grayscale textures. Let's create a new texture. In your program of choice, I'll be using Photoshop. Create a new texture with a 2x2 scale of 256 by 256 pixels. Add the cloud coverage and density that you want within the texture map and save it into Unity. I will save mine as tutorial_cloud_test in my textures folder in Unity. We now need to remove the gamma correction from the texture so that we are working with linear grayscale values. To remove the color correction curve, select the texture in Unity and in the inspector make sure that sRGB color texture is deactivated. Also set compression to none and click Apply. That's it for authoring textures for Unity's advanced volumetric clouds configuration options. At this point, I suggest pausing the video and experimenting with creating some texture maps to get a feel for how your custom textures affect the look, shape and feel of your clouds. Next, we will look at Unity's manual configuration options, which provide us with the most control over our cloud's distribution, density and shape, but requires advanced knowledge and is significantly trickier to implement well. The second of the 2 advanced customization options we'll look at is manual customization. The main advantage of manual customization over simple custom customization and advanced customization, which both come with limitations when customizing our clouds, is that we have complete control over all aspects of the clouds. We can control cloud coverage and rain throughout the horizontal axis of the sky. We can specify where and how we want clouds to be shaped in the vertical axis at specific regions within the sky. We can even specify how much clouds are affected by erosion and ambient occlusion in specific regions. If this does not yet make sense, bear with me, as it will all become clear shortly. The main takeaway is that once you understand Unity's manual customization, and with a bit of practice, there will be no limit to the skies you can create. Now that we have a high-level understanding of Unity's volumetric clouds manual customization features, let's look at how they work and how to set them up. For this tutorial, let's simply save the current scene as a new scene. Go to File and select Save As and save your scene with a new name. I will call mine Volumetric Clouds _manual. When done, click Save. Select the sky and fog volume, and in the Volumetric Cloud override in the Cloud Control dropdown, select Manual. Now, let's take a look at the manual settings. As with Unity's advanced cloud customization, manual cloud customization requires texture maps to render the clouds. Manual customization requires two texture maps simultaneously, Cloudmap and CloudLut, which stands for Lookup Table. And if one is missing, the clouds will not render. Each texture slot also requires channel packed textures. That means that each color channel in the texture, red, green and blue, contains a separate grayscale texture, each with a different purpose, and that Unity references to accurately render the volumetric clouds. For the Cloudmap texture, the red channel controls the cloud coverage or density over the horizontal axis of the cloud volume. The green channel controls the amount of rain in specific regions of the sky over the horizontal axis of the cloud volume. And the blue channel is used to map along the CloudLut Texture's horizontal axis to specify cloud properties at specific regions in the sky. This is where the real magic of manual customization happens. And bear with me, as it will become much clearer how this all works shortly. In the CloudLut Texture, the red channel specifies the cloud density over the vertical axis of the cloud volume. The green channel of the CloudLut Texture specifies the amount of erosion or shaping of the cloud within the vertical axis of the cloud volume. And the blue channel of the CloudLut Texture is used to specify the amount of ambient light visible in the vertical axis of the cloud volume. Let's look at how Cloudmap and CloudLut texture maps affect the rendering of clouds. We will go through how to author textures for manual customization shortly. In the meantime, let's look at the textures provided in the linked texture package, as they will help clarify how to use these textures to render the volumetric clouds. Select the Cloudmap texture. In the inspector, in the texture preview, you will see a colored square and circle on a black background. Select the red channel. With the red channel selected, you can see that the red channel contains a texture with a square and a circle. The red channel is what Unity uses to render cloud coverage over the horizontal axis of the cloud volume. Values of 0 or black equal no cloud density, and values of 1 or white equal full cloud density. Next, select the green channel. The green channel affects the amount of rain in the clouds. Values of 0 or black are equal to no rain, and values of 1 or white equal maximum rain. You can see that the circular area of cloud will have more rain, as it's the only area with a value of 1. Now select the blue channel. In the blue channel you can see two gradients. We added a radial gradient to what will be the circular cloud and a linear gradient to the square cloud. These gradients will be used to map values from the LUT texture. Again, this will become much clearer shortly. To see the Cloudmap texture in action, let's add the Cloudmap to our cloud volume. Select the sky and fog volume, and in the inspector, activate the Cloudmap, then drag in the Cloudmap texture. You will notice no clouds appear. As previously mentioned, Unity's manual customization requires two texture maps to render clouds. Activate the CloudLut and drag in the CloudLut empty texture. Two clouds will appear in the scene in the shape and coverage specified by the texture in the red channel of the Cloudmap texture, in this case a square and a circle. In the green channel we specified that we wanted the rain to appear in the circular cloud. To see how the Rainmap affects the clouds, activate the density multiplier and reduce the value to around 0.05. As you reduce the value, you will notice the circular cloud retains its density, making the cloud look darker, as if full of water and ice compared to the square cloud. Let's take a closer look at the CloudLut texture. The easiest way to understand how the CloudLut texture impacts the look of the clouds and how the blue channel of the Cloudmap texture is used to reference values in the CloudLut texture is to see for yourself. Select the CloudLut example texture and drag it onto the CloudLut slot. You can see that the clouds have changed their shape in the vertical axis of the cloud volume. To understand why we have the shapes we do, select the CloudLut example texture. In the inspector, in the texture preview, select the red channel. Let's now look at the cross-section of the square cloud. You can clearly see the shape of the cross-section of the cloud matches the shape visible in the CloudLut example texture's red channel. This shape appears because we are using grayscale gradients values in the Cloudmap's blue channel to map along the horizontal axis of the CloudLut texture. Let's take another look at the Cloudmap's blue channel to reinforce this concept. As you can see, the area of the square cloud contains a linear gradient from 0 or black to 1 or white. Seeing as the gradient is 0 to 1, we are mapping along the total horizontal axis of the CloudLut texture, which is why the square cloud vertical shapes matched the shapes visible in the CloudLut texture's red channel. Let's look at the circular cloud to see how the linear gradient affects the look of the cloud. You can see that we have the same shape, just rotated around the central axis of the cloud. You can create endless cloud shapes by manipulating the gradients used to sample the values from the CloudLut texture. One final point when using gradients to map values is that your gradients don't have to be values from 0 to 1. Drag in Cloudmap 2 texture to the Cloudmap slot. As you can see, where the square cloud was, we now only see the triangular cloud shape. This is because the gradient in the blue channel of the Cloudmap 2 has a gradient value from 0 to 0.5 and only samples the values from 0 to 0.5 along the CloudLut texture horizontal axis. Now that we have a better understanding of how the Cloudmap and CloudLut textures work together, let's look at the individual channels of the CloudLut texture and what influence they have. Drag the Cloudmap texture back onto the Cloudmap slot, then select the CloudLut example texture and in the inspector select the red channel in the texture preview. As we have just seen, the red channel lets us specify the density of the clouds in the vertical axis of the cloud volume. The green channel lets us specify how much we want the global shape factor to affect the clouds. The lower the grayscale value, the less influence the shape factor will have. To see how this works, select the sky and fog volume and set the shape factor to around 0.75. You can clearly see that the lower half of the clouds are affected by the shape factor, but that the top half of the clouds are unaffected, as the top half of the LUT texture is set to a value of 0 or black. The final channel, the blue channel of the LUT texture, controls the amount of ambient light in the clouds. The lower the grayscale values, the less ambient light will be visible. You can see that the top part of the blue channel in the CloudLut example texture has a value of 0 or black, and that the top part of the clouds in the scene view are dark where ambient light would usually be. That concludes the manual customization options. Although manual customization offers the most control over Unity's volumetric clouds, authoring textures takes time and practice. We suggest experimenting with creating textures, and from our experience, once you start trying things out, you quickly gain proficiency in creating great-looking clouds and skyscapes. Showing how to author textures for Unity's manual customization options exceeds the scope of this tutorial. However, some tips we can give you is to start by shaping your clouds using just the Cloudmap. Once you feel comfortable with that, you can start playing with adding gradients to map values from a CloudLut texture map. If we get over 1000 views, we will create a dedicated tutorial showing our workflow for creating textures for manual cloud configuration. One point to note is that when importing textures, be sure to remove the color correction curve. By selecting the texture and in the inspector, make sure that sRGB is deactivated and compression is set to none. That concludes the advanced and manual customization tutorial on Unity's volumetric clouds. You now know how to leverage Unity's advanced and manual volumetric cloud configuration options. At this point, I highly recommend playing with these properties to better understand how they work. With a bit of practice, you can create infinite cloud variations and any cloudscape to suit your project's needs. If you have questions, please comment below or use the contact details you will find in the video's description. Stay tuned for a few quick time lapses where we create clouds using advanced and manual configuration options.